This is your Ghana mathematics teacher. Today we are going to continue on our discussion on algebraic processes. And the topic to be discussed today would be simultaneous equation. In the previous discussions, we have solved problems on algebraic expressions and or equations in one variable, vis-a-vis quadratic expressions and quadratic equation. In all of these, we have solved problems on algebraic equations in one variable. But in simultaneous equation, it involves more than one variables. As a matter of fact, it can extend up to 4 variables depending on the level of mathematics that the topic is being discussed. But at the intermediate level, I'm only going to discuss the ones that involve 2 variables. So let me state that simultaneous equation may be solved using about 4 methods. The first one being the first 2 being analytical, while the other 2 are usually suggested. Now, for instance, you may solve simultaneous equation using, these are the 4 methods of solving simultaneous equation. One thing I emphasize a lot in every of the discussions I've done in the past. One thing about mathematics is knowing what to do at any given time. So, how are we going to decide which method to use? Like I said, the first 2, you can decide which method to use with the first 2. But the other 2, you have no choice. Usually the machinery are already set in motion and you just have to tag along. Now, graphically, you will be given a graph, and the graph of one of the equations will already be plotted on the graph, and you'll be told to copy and complete the table of value for the other equation, and you will be told to proceed to plot the graph of that equation on the same axis. So in that case, you have no choice. You just have to tag along. And as for matrices, on very rare occasions, are you likely to be told to solve using matrices? But then, in any case, I'll still get there as time goes on. In the interim, I am going to discuss solution by elimination method. You may be told to solve these equations simultaneously. Now, I have mentioned that we are solving using elimination method. The first thing to look out for is, do you have any of the variables? In this case, we have x and y. This system of linear algebra is in x and y. So the first thing to ask is, do we have any of the variables, that is either x or y, whose coefficients in both equations are the same? The answer is yes. That is because the coefficient of x in both equations is 2. So we just go straight away. We now say equation 1 minus equation 2. And why are we subtracting? That is because the signs in front of both variables, the coefficients of the same variable, are the same. If the coefficients are both positive, subtract. If the coefficients are both negative, subtract. The first thing to establish is that, are they equal? Yes. Do they carry the same sign? Because when you have the first term, the positive sign will not necessarily be written, but then we understand that it's a positive sign that is here, and it's also a positive sign that is here. So when that is the case, we eliminate this, meaning that this will be subtracted from this equation 1 minus equation 2. And what do we do? Going by the principle of corresponding terms, we are subtracting this x term from this x term, and that eliminates this. So now we have 3y being positive here, minus y, and that is going to give us 4y, because the minus becomes positive, and that leaves us with, if we subtract 2 from 10, we are going to be left with 8. Now we have a simple linear equation in one variable. So what would y be? We divide through by 4. It implies that y is equal to 2. Then we can substitute in any of the equations. Now, when I say substitute, it does not mean that we are using substitution method. So in that case, what do I suggest that people use? I say putting y equals 2 in. I also suggest that one applies it in the equation with smaller number because it's easier to manage. In any case, when you become good at it, it really doesn't matter where you are applying it. But then, at the stage where you are still learning, I advise that you put it in the equation with the smaller number. In this case, this equation is smaller. So in equation 2, it now implies that 2x minus 2 is equal to 2. So 2x, collecting like terms, equals 2. When this 2, negative 2 crosses here, becomes plus 2. So 2x is equal to 4. We do the same thing, divide through by 2. Then x is also equal to 2. The solution therefore, x comma y is equal to 2 comma 2, meaning that x is equal to 2 and y is equal to 2. And what we have here, if we substitute the values into these equations, are they going to be consistent? Now let's check. 2 times 2 is 4. 2 times 3 is 6. 4 plus 6 is 10. Consistent. 2 times 2 is 4. Minus 2 is 2. So it's consistent. Now the values that we get will be such that they will satisfy the both equations. And if there are more than 2 variables and also more than 2 equations, all the values of the variables that will be obtained will satisfy each of the equations. And that is when the system of linear algebra is said to be solved simultaneously. Okay, now, like I said, the first thing to consider to determine whether to apply elimination method is, do we have any of the variables whose coefficients are the same in both equations originally? The answer is yes in this case. So I'll solve another one, in which case the coefficients are not necessarily equal in both equations, but then we will still apply elimination method. So if we are given something like this, 2x plus y equals 5, equation 1, and 5x minus 2y equals 8, equation 2. From what we have here, it is easier to solve it using elimination method, even though none of the variables has equal coefficient both in equation 1 and equation 2. However, the coefficient of y is such that is 1, so that we can easily multiply through equation 1 to obtain equation 3, in which coefficient of y will be equivalent to the coefficient of y in equation 2. So knowing that, and the positioning will be perfect, so we now say from here, equation 1 times 2. Why are we doing that? Because we want to ensure that the coefficient of this y and this are going to have the same absolute value. In any case, they are going to become additive inverses. I will explain that subsequently. So we multiply equation 1 by 2, and that gives us 4x plus 2y being equal to 10, equation 3. Some people would want us to multiply equation 2 by 1 and rewrite it down. Then it doesn't make sense in my judgment, because it's a waste of time. So the most important thing is that the equation 3 we are applying here is obtained from equation 1. So we are still working with the 2 original equations, because this is a multiple of this and it is still consistent. Now we have successfully obtained 2 consecutive equations in which the coefficient of one of the variables are equal, although the signs are not the same. As against the previous example where we had to subtract the equation 2 from equation 1 because x had original equivalent coefficients. In this case, we are not going to subtract because the signs are different. In other words, they are additive inverses. And additive inverses are two terms, two integers that add up to give us 0. So because they are additive inverses, we just say equation 2. In this case, we obtain the equation 3 from equation 1. So we are done with equation 1. Equation 2 plus equation 3. And that gives us 9x. This is eliminated because they are additive inverses. Negative 2y, positive 2y will be equal to 0. Equals, when we add 8 and 10, we get 18. So divide both sides by 9 and by 9. X is equal to 2. The same way we did putting x equals 2 in, we can still apply it in equation 1 because it's a lot easier in equation 1. In equation 1, so we now say 2 into 2 plus y is equal to 5. 4 plus y is equal to 5. Y now is equal to, when this 4 crosses to the other side, in the spirit of collecting like terms, we now have 5 minus 4. So y is equal to 1. Therefore, x comma y is equal to 2 comma 1. And this is how the solutions are presented. Like I said, the positioning of this will determine whether we should apply elimination method. Now, I will solve one more example of instances where we will decide to apply elimination method. Okay, we may have something like this, and we'll be told to solve them. Of course, if we have something like this, the first thing we observe, like I said, is that we do not have equal coefficients for any of the variables in both equations. That is 1. 2, neither of the variables has a coefficient of 1 in equation 1. So, at this point, we have to find a way of obtaining equal coefficient for one of the variables. Now, at this point, this is a value of decision. We determine the lowest common multiple of this is 6 and the lowest common multiple of this is 15. Now, incidentally, the coefficients all through are prime numbers. So, we determine the lowest common multiple of this one being the smaller lowest common multiple. Like I said, it's important to choose the one with smaller number for it to be manageable. In other words, you don't have to rush to your calculator to multiply things out. So, when we are given something like this, we now say, equation 1, we have made up our minds now to obtain equivalent coefficients for this. The lowest common multiple being 6, being the smaller one. We now say equation 1 times 2, and that will give us 6x plus 10y being equal to 26. That is equation 3 now. Then equation 2 times 3 will still give us 6x plus 9y being equal to 24, equation 4. Now, this is the only scenario in which we are expected to get another, generate two new equations. In any case, we have obtained equivalent coefficients for one of the variables, which is x in this case. So, what do we do? Like I said in the previous example, the signs here are both positive. So, the next thing to be would be equation 3 minus equation 4. And that will give us this will be completely eliminated and we are going to be left with y. If we subtract 9y from 10y, we are going to be left with y. If we subtract 24 from 26, we're going to have 2. So it is straightforward, no simpler solution. We'll just substitute it in one of the equations, but preferably equation 2 because it has smaller coefficients. So putting y equals 2 in equation 2, it implies 2x plus 3 into 2 equals 8. 2x plus 6 equals 8. 2x equals 8 minus 6. 2x equals 2. Therefore, x equals 1. The solution now will be x comma y equals 1 comma 2. So these are the 3 presentations of solution by elimination method. Let me say for the record that it is not important, it is not mandatory that the coefficients would be integers. The coefficient of any of them may be a fraction. So let that be understood. However, when we get to the bridge, we can always cross it. And in this discussion, we are going to solve simultaneous equations using substitution method. Okay. Now, in this case, like I said in the previous video, I talked about one of the conditions that will be satisfied for us to consider applying elimination method. And one of it is that the coefficient of one of the variables is 1, while the coefficient of the other in the other equation is not 1. So we can easily multiply that equation by the coefficient in the other equation. But in this case, the positioning does not, favor us. How do I mean? Supposing this 3x plus y equals 8 is in equation 1, and the 5x plus 2y equals 15 is in equation 2. It would be advisable for us to simply multiply equation 1, that is, if this were to be equation 1. It would have been advisable for us to multiply through by 2 to obtain equal coefficient for y in 2 consecutive equations. But in this case, if we attempt to multiply this by 2, we generate, in that case, we'll have to bring this down and multiply this by 2, so it doesn't make sense. Instead, we simply apply substitution method because one of the variables has a coefficient of 1. And the good thing is that the coefficient is even positive 1. So what do? We now say from equation 2, because it's in equation 2, we have y having a coefficient of 1. We now say y equals 8 minus 3x, and that becomes our equation 3. Now, we have generated equation 3 from equation 2. So, we now have to substitute it in equation 1, thereby having an equation, a linear equation in one variable. So instead of this y now, we are now going to put 8 minus 3x then equals 15. This is substituting equation 3 into equation 1. Now we have a single variable. It implies 5x plus, if we open this bracket, 2 times 8 gives us 16 minus 6x being equal to 15. Now we collect like terms. It implies 5x minus 6x is equal to plus 16 is equal to 15. So we now have negative x is equal to 15, this crosses here, negative 16. So negative x is equal to negative 1. So x is equal to 1. We now substitute for x in equation 3, because in equation 3 we already have y being made the subject of the formula. So we simply substitute into this. So we now see, so it implies y equals 8 minus 3 into 1. Y equals 8 minus 3. Therefore, y equals 5. The solution now is x comma y equals 1 comma 5. So this is the condition that will make it advisable for us to apply substitution method when the coefficient of one of the variables is 1, and it's only one variable that has that coefficient, and that variable falls in equation 2. So the most reasonable thing would be to make that variable the subject, since we will not have to divide through by any other coefficient, and we substitute in the other equation, which is equation 1. It is not as if you have it in equation 1, you couldn't have applied substitution method, but then elimination is a lot easier if it is in equation 1 and the corresponding variable in equation 2 has a coefficient different from 1. So you simply multiply equation 1 by that coefficient in equation 2. But in this case, this is what is best for us. So this is how to solve simultaneous equation using substitution method.